Hi, my name is Ms. Townsend and I love math. This is a quick video for data management students who are studying for the exam. Now this question that a student asked me to do isn't actually from your exam review. It's from the work we did in the final unit on probability distributions, but I figured I would do it anyway because it's all good. So the question is that six coins are tossed. If an even number of heads turn up, the player wins $10. If an odd number of heads turns up, the player loses $12. Let X be a discrete random variable that represents the amount of money won, and then we have to create the probability distribution and find the expected value. So we know that because we're creating the probability distribution for X, there's only two possibilities for what the values that X can take on. At the end of this experiment of tossing 6 coins, either you have lost $12 or you've won $10. So I just have to figure out what the probabilities associated with those are. So in order to figure that out, let's look at the experiment. So the experiment is we're going to toss 6 coins. So we know that there's a sample space. So every coin has 2 possible outcomes. And I'm going to do 6 coins. So 2 times 2 times 2 times 2. Each coin has 2 outcomes. They're all independent. So I could also just say 2 to the 6. So there's 64 different possible outcomes. So we know that if an even number turns up, that we're going to win money. So an even number could be 0, 2, 4, or 6 heads. And that would give me $10 because those are all even numbers. So I need to calculate the probability of each of these things occurring and then add them together because they're all different cases that mean I've won. So for example, to get 0 heads, I need all tails. So there's only one way of that happening because it's just tail, 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 tail. No point rearranging it. So that one's done. To get 2 heads, so head, head, and then the rest tails. So here's an example of what it could look like. Well, that is 6 objects, 4 of which say tails, 2 of which say heads. So that is 6 choose 4. That is 15. So the probability of getting 2 heads is 15 out of 64. So now I'll do 4. So 4 heads, head, 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 tail, tail. You'll notice this is exactly the same as what I just did because 4 heads and 4 tails, mathematically, same idea. So this is also 15 out of 64. And then to get 6 heads, well, you have to get heads all the way. There's only one way of doing that, get heads. So that's 1 out of 64. So in order to get an even number, I need to have 0 heads, which is 1 out of 64. Oh, where's my pen? So I need to add the probability of 0 heads, probability of 2 heads, the probability of 4 heads, and the probability 4 heads, and the probability of 6 heads. So if I added all those numbers together, I would get 32 out of 64. So the probability of getting $10 is 32 out of 64. And then you could just use subtraction to calculate the other one, but let's actually do the calculations for the other for losing $12 and just make sure that it all adds up to 100% of the possible outcomes. Ooh, I'm on a... This is a slow erase. I apologize, but, you know, whatever. Take this time to think about stuff. All right. I can't be bothered to erase the whole thing. All right. So if I lose $12, that means I've tossed an odd number of heads. So an odd number of heads... Oops. Get my pen back. So an odd number of heads is either 1, 3, or 5. So the probability of getting 1 head, so it's still a sample space of 64. There's an example of what 1 head would look like. So you can also visualize that as 6 things being arranged, where 5 of them are repeatedly tails. So that is 6. So 6 out of 64 is the probability of getting 1 head. That equal sign is bothering me because that's not what I meant. Now to get 3 heads, I need something like this. There's 3 heads, so 3 tails. And to get that, I need to have 6 items, 3 of which are repeated, 3 of which are repeated. So there is a total number of 20 ways of that happening. 20 out of 64. That's the probability of getting 3 heads. And then 5 heads means 5 heads, 1 tail. So again, I've got 6 objects, but 5 of them are repeated, so it's the same math as earlier. That's 6 out of 64. So 6. So if I want to get an odd number of heads, I can get either 1 head, 6 out of 64, or 3 heads, which is 20 out of 64, or 6 heads, which is 6 out of 64. So if I add those together, I've got 32 out of 64. And of course, that's nice to check because I can quickly see that yes, these both reduce, and I'll do that in a second, but obviously the 32 plus 32 is 64, so I've got all of them. So that's my probability distribution. If you want to reduce, there's actually a half and a half. To get the expected value of x, I need to take negative 12 times a half and add that to 10 times a half. So that's negative 6 plus 5. So you expect to lose $1 every time you play. And of course, that's just on average. And of course, don't gamble.